Hi, I'm Josie Foss, Executive Director of the Progress and Poverty Institute in Princeton. I'm joined today by Chester Harvey, who is the Director of the Transportation Policy Research Group at the University of Maryland's National Center for Smart Growth, and he's also an Assistant Research Professor in Urban Studies and Planning. He holds a PhD in City and Regional Planning from UC Berkeley, and his research uses data science and mixed methods to examine how urban design shapes pedestrian accessibility, behavior, and well-being. Today, we'll be discussing a PPI-funded research project led by Dr. Harvey titled Proof of Concept, Land Value Modeling in Baltimore, Maryland. Dr. Harvey, thank you so much for joining us.
Thanks for having me.
So my first question for you, tell me a little bit about yourself and how this project relates to your other research interests.
Okay, well, I'll try to go off of the lovely introduction that you gave me there. So as Josie mentioned, I'm a urban planner, I'm a data scientist, and a lot of my research has to do with transportation and with data related to it. And this project is more in the space of land use and how those land use systems relate to transportation. That's actually a part of it with access to different types of destinations. And then for my co-authors on this study, Nick Finio and Casey Dawkins and Eli Knapp, all of them are in the community development and housing spaces, again, sort of relating land uses and transportation systems and understanding how the value of land is related to what you can get to from it. So we came into this project from all of those different lenses, and also the different research centers that we're all affiliated with. So I'm at the National Center for Smart Growth at the University of Maryland, and along with Nick and Casey, and then Eli Knapp is at the Center for Open Geographic Sciences at UC Irvine. And all of those centers are really interested in how we can use data and statistics tools to support public policy. And so this project fits into that space really well as well.
Yeah, it absolutely does. So, can you talk a little bit about this project? What were sort of the goal setting out, to do the research? What did you have in mind?
For sure. So the goal of this project was, as the title kind of insinuates, to be a proof of concept of whether we could realistically predict the value of land as a component of the value of total properties based on publicly available data sets. And we used the city of Baltimore as a sort of case study for that. The city of Baltimore was convenient for us because we have really strong relationships with data providers within the state of Maryland, including the Maryland Department of Planning, which has been collecting data on properties for decades now in Maryland. And because Baltimore also has a really wide variety of land uses within it, different types of residential land use, including a fair amount of vacant property, which was actually convenient for this project since we're studying what happens to the value of property minus the improvements or the structures that are on it. So we're aiming to develop that proof of concept that really this would be possible and sort of a gut check on how well a statistical model would predict land values, and how that would relate to features that we see on the land, things like where the harbor is, where downtown is, relationship to transportation services, relationships to things like parks and schools and other characteristics that would impact theoretically the value of land. And then finally, on a more sort of technical note, we were interested in whether some more advanced statistical methods would be useful in that prediction. And so we tested a few different types of models, and some of our results are around how well or not so well those more advanced methods worked for us.
Absolutely. I know that this work was a little bit of an adventure, with some course corrections and a lot of really good thought into how to do this the best way. Can you talk a little bit about the methodologies that you used, what worked, what didn't work, and how did everything evolve over the course of the project?
Yeah, so we did, as you mentioned, have a lot of evolution. I guess I'll speak to this from two different sides. One would be getting all of the data together that was necessary to do this work, which was easier said than done. And then also the modeling side of things. Once we had the data in place, how did we operationalize that into these estimates of land values? So on the data side of things, as I mentioned, we do have this really close relationship with the state of Maryland, and they've got this property data set, including sales that go back decades. And so we took a more recent slice of that. We were looking at the I say last 10 years, but I think we were looking at 2013 through 22. So several years historically now. 10 years worth of sales data. And we were looking at sales because sales provide, you know, good observational evidence of how much a property is worth. It's not just an assessed value. And then we needed to compile all sorts of sort of property characteristics and neighborhood characteristics onto that data set. And I think we went into this thinking that we wouldn't have quite as much missing data as we did, and so there was a fair amount of trying to figure out how to creatively sort of access different property and neighborhood characteristics, um, and figuring out basically what we could represent. Consistently across the whole data set. And I would say ultimately we really had challenges around some of the improvement value related things, things like number of rooms, types of room, types of structures, et cetera, that are available for many records, but weren't as complete as we hope they would be. And I think that that's very commonly a problem with any sort of assessment studies. And then another issue that we ran into, which I think I'll get into a little bit more as we talk about results and take-home message, takeaways from this work, had to do with how that data was aggregated and organized. There were a lot of things represented that we commonly represent in public data within, say, census boundaries. And those sort of aerial units, which are what we in sort of geographic science would call fiat boundaries. They're not like real natural boundaries. They're kind of meaningless in terms of policy, but they're the units in which we organize things like demographics, and so you end up with boundary issues where you can say the income within this sort of aerial unit is one thing, and then just across that line it's a different income, even though those points are really right next to each other in space, and that's a simplification that's necessary for a lot of research. But when we're looking at the value of properties, which are really precise locationally, those end up making a huge difference. And so we spent a lot of time trying to figure out how we would better represent that in a way that didn't distort the outcomes. Um, and ultimately, I think that posed some real challenges to this. On the modeling side of things, we ran into a lot of kind of classic modeling problems with many variables that were all highly correlated with one another. We ran into that sort of like blocky data problem that I was just describing. Another thing that this research really was based on methodologically, and I won't get into the sort of gory details of it, but we make an assumption that the value of a property is composed of essentially two parts, the land value and the improvement value, or what's built on it. And statistically, we then say, well, if we take the total value of the property and we subtract the part that is attributable to the improvements, then the result is the land value, and that's the sort of methodological approach that we pursued this with, and in a lot of cases, it was actually more difficult to do what we call decomposing those parts than we went into this with, and trying to figure out sort of how to structure the model so that those can be decomposed is a classic problem in what's called hedonic price modeling. That's the sort of academic term for what we were doing. But that was just struggling with how to design it so that it could be effectively decomposed ended up being an issue for us. Um, and then finally, we were trying to figure out sort of the role that these more advanced spatial statistical models would play. And you know, we're trying to figure out basically whether they added a lot of value to the outcome versus maybe that complexity being, um, just additional complexity without much of a benefit. And I think that there's still a fair amount of room for additional work in that area. Maybe we'll sort of get into that further in our conversation, but it wasn't immediately obvious that they were truly necessary for the sorts of land value predictions that we had, in part because of just some of the limitations of how we um, understand spatial relationships. And this gets into sort of the technical aspect.
No, that's all really interesting and relevant. And I think for the average person, if you're in this space at all, then you've definitely heard someone say it's really hard to value land, right? But for
Yes.
the average person, I don't think that's intuitively obvious. We transact land all the time. So how could it be hard to determine, how much it's worth, right? But clearly this study, which, you all just did so much to try and get to the to the answers, right? It really illustrated just how difficult it really is. And I appreciate you kind of walking us through the different elements of the work and kind of where the wheels came off in different ways, because it is really complex and interesting, and I think really valuable to understand that. Despite the challenges, the work did produce a number of different findings. Can you talk a little bit about those and how you think those could be used in the future? And also, what's unanswered at this point?
Yeah. So we did develop this surface of land value, and we developed that specifically for residential properties within Baltimore. That was the type of property for which we had enough sales data to sort of confidently build that model where we could decompose land value from improvement value. And so, in some sense, we demonstrated that this was possible, and it produced realistic valuations. I think an area that definitely we need to sort of move forward with more as a field is, how do we do that assessment of realism? To some extent, this for us involved examining the outputs from the model and saying, well, are there sort of artificial artifacts, things like, borders where, as I was describing earlier in our conversation, you move from one side of a line to another, and all of a sudden the price jumps or deflates. Is that a realistic representation of what's changing in space? And it very well could be, if there's a real natural boundary there, something that's difficult to cross, or whether you're in a different school district, for example, where even from one side of the street to another, there are meaningful differences in the land value, then that's appropriate. If you sort of zoom into the results and that just looks like an artifact of blocky data, then that poses a problem. On the other hand, what we were not working with in this project, and we knew this going into it as a limitation, was some sort of ground truthed land value all by itself. We had ground truth sales values, which included sort of both parts of the value composition. But definitely something that could and should be taken forward is some sort of validation against land values that would be developed independently in a slightly more grounded way. Because what we can conclude from this is it's possible to estimate it, and that it looks realistic, on sort of a gut check level. Um, Another thing that we sort of ran into with this is that these values, while they were realistic in terms of how they look on a map, we don't have as much confidence in their precision as I think we would have liked to, and that stems from the fact that we weren't able to include as many variables in the predictive model. So we really would have liked to have included, as I described earlier, more things about the improvement characteristics. The variety of even things like number of bathrooms or number of bedrooms. We had, information about square footage. We had information about the sort of type of the structure and the quality of the structure. But in the grand scheme of say real estate research, that's not as many things about improvement, and therefore we weren't maybe able to as precisely identify the improvement value, and therefore the land value as the inverse of that, as we perhaps would have liked. Um, and then, of course, this was a evaluation of residential properties. We didn't have nearly the scale of sales related to non-residential properties. And in principle, a lot of the characteristics should be pretty similar. You should be able to take things you understand about residential land and apply them to commercial areas. The real hitch there is zoning. And while we did look at zoning within the context of the model, and in particular, we're looking at differences between single family zoning and mixed use and so forth. There's just value inherent in commercial and industrial zoning that were not represented here. And so those were holes basically in our surface of the city. Um, so those were some of the main findings that we had, and then things that we, sort of would have liked to add, or that I think there's definitely room for room for future studies to be looking at. Um, I think in terms of major takeaways for other researchers, our stumbling blocks in this were um, not being careful enough from the outset about the role that these kind of arbitrary aerial units would play in biasing our results. So we actually spent a lot of time knocking our heads against this issue where the model was inappropriately attributing way too much value to land, which in some ways felt like a good thing, but that artificially deflated the price of or the value of the improvements in a lot of cases actually into negative territory. So in order to come up with a realistic overall sale price, you know, let's say of $750,000, the land would be attributed $1 million, and then somehow the improvement value, the model was attributing like negative $250,000, which is really unrealistic. There are a few cases, or maybe at most like 1% or 0.5% of properties within Baltimore, which is more than typical, where you do actually have negative improvement value if they're condemned structures. But we were dealing with a magnitude much greater than that. And we finally figured out that this was really due to a sort of spatial statistical anomaly where when we were using data aggregated within census tracts or block groups, things that had these kind of artificial boundaries, that properties that were just on either side of one of those boundaries would have kind of like unrealistic values that were representative of the whole area as opposed to like that particular location within the area. And so as soon as we either sort of like removed those factors or figured out how to better account for maybe like an average across that boundary, those problems went away. And that was an interesting sort of diagnostic statistical process, really in the weeds, but just like to help understand why we were finding these really unrealistic results. Um, and then, sort of similarly in the weeds, some of the spatial statistical methods we were using were encountering really quite similar problems, where they were understanding, relationships between a property and its neighbors, but not, but within a sort of definition of neighborhood that was a little bit too blocky. And so really, I think researchers should be trying to either better represent sort of like natural shapes of neighborhoods as opposed to, an artificial, the easiest type of neighborhood to draw on a map, of course, is a circle, but a circle may not really represent the sort of sphere of influence of a property, and so we need to try to figure out how to represent that sphere more realistically, um, and that will be, that's certainly a space that spatial statistics can go into, but that we weren't able to drill all the way down to with this project.
Yeah, wow. That it's really interesting to hear you talk about the technical side of the work that you've been engaged in, because I think for those of us who don't do the work ourselves, like there can be an assumption of, oh, the data are out there and the statistics are out there, and it's just a matter of getting the person who knows how to combine those things and get the answers. And I think what this experience has demonstrated is you can be absolutely, skilled to do the work and have the data, and then things come up when you do the analysis that maybe you didn't anticipate, and course corrections can be needed. So I think that this was a really interesting project to see you all working on and watching the methodology evolve, as you were recognizing some of these limitations or some of these issues that were cropping up, and how can you address those while still working towards that same end goal, right, of understanding land values. So I think this was just
Yeah.
a really neat project. Is there anything that I didn't ask you about related to this work that you feel like we should talk about?
I mean, I feel like the way that you just described, not taking the data for granted, and like not making this assumption that like everything is just there ready to be analyzed, all in the right structure, is one of my biggest take homes from this project, and that the sort of sometimes unrealistic structuring of the data really makes a big impact when we're talking about something as precise as a property. So I think that yeah, that gets at what I was hoping to be able to discuss here.
Yeah, well, thank you so much for sharing this experience with us and your findings, and honestly for helping to kind of make clear that, no, this isn't just a kind of assessor saying it's hard to do. It's genuinely hard to do. It's not impossible, but there's real work to be done to get accurately at values. So,
Yeah.
well, Dr. Harvey, thank you so much for speaking with me today, for working on this project. As I said, this has really been a kind of an interesting one to watch you all working through, and I think we've learned a lot, alongside you as you're doing this project.
Terrific. Thank you.